Hello, class. Welcome to 9C, the last part of Chapter 9. And this is to do with hypothesis testing for one population. Now, we did see the or rather the 8 steps in conducting a hypothesis test. And so let me quickly take you there. So a quick recall. We had the first step where we identified the claim. Step 2 gave a symbolic form, the mathematical notation. Step 3, we found H0 and H1 null and alternative hypotheses. Step 4 was to select the significance level, the alpha value. If it's given in the problem, we'll use that. If not, we will use 0.05, the 5% level. And step 5 was to identify the test statistic. And for step 5, let me take you quickly here. We used this table to determine which test to perform. If the question was, if the claim was to do with proportions, meaning if it came as a percentage, or so many people said yes to, out of this many who were surveyed, that kind of proportion. So it can come to you as a percentage, or it could come to you as a number. This number of people said yes to this, or this number of people said no, if no was your interest, out of the total surveyed, and so on. So proportion would use the first row. If you were trying to test the claim related to mean, they said the mean, the mean time for oil change is this, the mean time for a breakfast drive-through order was this, whatever could be the background. If the claim was to do with mean, you had two options. So what happens if you knew what sigma was, and if you did not know what sigma was, and so on. If we didn't know what sigma was, we would use T. If we knew sigma, we would use this formula, because you have a place to plug in for sigma. Here, if you did not, oh, I'm just noticing this. This is when sigma is known. Okay, that's better. That's when sigma is known, because when sigma is known, you can plug in for sigma. When sigma is not known, then we use the sample standard deviation, and that's what this says. Okay, so that was your step 5. The step 5 would give you an answer from the last column here, test statistic. Step 6 branched off into 2 parts. You could either do the p-value method, which is what we use in the calculator, or you could use the critical value method by drawing the graph and finding the critical region, the rejection region. And you would make decisions in step 7 based on whichever method you chose. And both those decisions must point to the same answer, the same decision, because they were just equivalent methods. And then step 8 was when we used a decision chart, I'm sorry, the conclusion chart that we would use for concluding the claim. So this was the chart. So if you had these conditions, this is how you would write out your conclusion. The language has to be maintained the way it is written here, okay? So we're going to use all these things in this problem. A medical billing specialist would like to test the claim that the proportion of patients with high deducible health plans who have overdue medical bills is greater than 65%. They sample 90 patients with high deducible health plans and determine the sample percent to be 80%. At the alpha equals 0.1 level of significance, test the claim. Okay, let's go back and understand this question. It sounds, it's a little high sounding, so let's see. A medical billing specialist would like to test the claim that the proportion, okay, we got a hint there, that the proportion of patients with high deducible health plans who have overdue medical bills is greater than 65%. Okay, so these patients, the proportion of these patients who have this particular plan have overdue medical bills, and they found that the proportion of such patients was more than 65%. Therefore, they sample 90 patients. So there are 90 patients in the sample size. And these are the patients with high deducible health plans, right? You want to make sure that you're surveying those patients. And then they determined that the sample percent came to be 80%. So at the alpha 0.1% level of significance, test the claim. And then they have A, B, C, and D. These are basically the steps to conduct the test, hypothesis test. Okay, They didn't tell us which particular method, p-value or critical value method. So we'll start off by using the p-value method, which means we can use the calculator. And let's try to understand how this works. Okay. So we'll start off with answering part A. Okay. Part A is identify the null and alternative hypotheses. Now this is technically step 3. Let me take you here. This is your step 3, identify null and alternative hypothesis. So you'll have to do indirectly steps 1 and 2 to even get to step 3, right? So let's do that here. So step 1 is to identify the claim. Okay, so remember, we have to go back to the question and remove all the clutter to see what the claim is. The claim is that the proportion is greater than 65%. So let me write that. Proportion of those specific patients. I'll just say patients. These are the patients with the high deducible medical plan, okay, and who have overdue bills. So proportion of such patients is greater than 65%. Okay, that is the claim. Step 1 writes the claim in words. Step 2 says, okay, now that you got the claim, put that in a symbolic form. The symbolic form, this is for all such patients. So this is the population, right? So population proportion has the symbol P. Okay, P hat is for sample proportion. P is for the population. The claim is always about the population. So greater than is greater than. 65% is 0.65. So we wrote that in symbol notation, symbolic form. Then this is step 3, which we are actually asked in part A, right? So H0 and H1. H0 always carries the equal sign. So whatever you have in step 2, just write that with an equal sign. And H1 is what you have there with the inequality. Okay, so that is your claim. Okay. A quick check. If the claim said the proportion of patients is 65%, okay, I'm going to erase this after I explain this, but just a quick notation for you. If they said proportion is 65%, that means P equals, because S means equals, 0.65. And then if that was your step 2, then in step 3, you would write the one with the equals and call that as the claim, because your claim already had the equals. Because your claim had the equals, your H1 must be the opposite of it. So you'll say not equals 0.65. Okay? Your claim is equals, but your alternate hypothesis is not equals. But in this particular case, the actual problem, your claim came as an inequality. So your H0 took the inequality, and we use the inequality in H1 and call that as a claim. I hope that makes sense. Okay. So only when you have is in your claim that your claim will match H0. Otherwise, your claim will usually be in H1. So I'm going to kind of clear this so that you're not confused with that, because that's not part of the problem. All right, so that was A. Let's answer B. B says calculate the test statistic. So go back here. Calculate the test statistic is step 5. So we have a step 4 in between, right? So in step 4, we need to find alpha. Go back to the question. They gave us alpha to be 0.10. Come down here. There's alpha is 0.10, 0.1. Okay. Now, because this is to do with proportion, we go to the chart and we use the first row. So we need to check the requirements, and once the requirements are satisfied, we go ahead and do the test statistic. So let's come back here. I'll say check requirements. NP must be greater than or equal to 5, and NQ must be greater than or equal to 5. Okay. So our P is 0.65. And what is N? N is given to be how many people were surveyed. So they sampled 90 patients, so N is 90. P is the proportion from the population, and that was 0.65. So do 90 times 0.65. And Q will be 1 minus P, right? So you're doing all this in your calculator. And 1 minus 0.65 comes out as 0.35. And so for NP, you'll have to multiply the 90 times the 0.65. That's 58.5. This is greater than or equal to 5, so we're good there. Then do 90 times, for the Q, it's 0.35. And 90 times 0.35 comes out to be 31.5, which is also greater than 5. And so the requirements are satisfied, which means you could use the test statistic. Will be Z. Come back here. Z is P hat minus P over square root of PQ over N. Okay. And come back here and see what P hat is, because we have all the others. P hat is what they gave us. P hat is given to be 80%, sample proportion is P hat. So P hat is 80%, so P hat is 0.8 or 80. So that's 0.8 minus P is we just saw that here, right? P is 0.65 divided by square root of 0.65 times 0.35 all over N is 90. Okay. Pull out a calculator and find the value for this. So what we see here is that it comes out to be 2.983470949, okay? Which you can, kind of round it to 2.983, if you will. And that is your test statistic. So we answered part B. And we did this manually. So I'm coming to the calculator part. It says find the p-value. C is find the p-value. Again, you could use the table method, or you could use the calculator. I just want to use the calculator to kind of teach an important point here. So you could have used the calculator to find your test statistics. So we're going to check that too. Let's do that. So if you are using TI-84 plus, like I do, TI-84 plus. So here what we do is we go to stat button. Then from there, go across to the calc tab. I'm sorry, the tests tab. I should do tests. Change that, tests. And then if you go, the first one, it says Z test. So that is just to find the Z test and the T test. Then you have 2 sample Z, 2 sample T. Skip that. Go to 1 prop Z test. Okay. So that is actually number 5. Okay. 1 prop Z test. Okay. In fact, if you recall, if you move down to step 7 actually says Z interval and T interval and all that, right? So, and then if you go down, it says 1 prop Z interval. And so that is what we use to find our confidence intervals, right? So if you recall, you've been to this tab before. You've used the one way at the bottom. You used 1 prop Z interval, and then you also have the T interval and so on. So here we are focusing on the test, not the interval. So I want you to make that difference there. Okay. So we'll go to 1 prop Z test, which is number 5 in my calculator. And then it shows you these prompts, okay? So you have P naught, And then you have X, then you have N, and then it says prop not equal to P naught, less than P naught, greater than P naught, and then it says calculate. And then it says draw as well. Let's focus just on the calculate. So you'll have to enter values for all of these, right? Yeah. Now P naught, as you can see, here if you see this prop equal, not equal to P naught, less than P naught, greater than P naught, this is the setup where P naught is the notation that the calculator uses for population proportion, okay? So this is the population proportion. So this comes from the claim. Your claim is 0.65, so you want to enter that as 0.65. Then it asks for X and N. N we know, let's come to X shortly. You know N is 90 because that's your sample size. And if you go here to step 3, right, your H1 is P greater than 0.65, or in other words, your step 2, where you built your claim. Your claim is P is greater than 0.65. So this is what you will choose because that's your claim, right? Now, if we enter the X, then we got it. You can go click calculate and get your answer. To find X, X is the number of people, right? In this case, the number of patients, right? X is the number of patients with that high deducible medical plan with overdue medical bills. Those are the number of patients, okay? So these are the number of patients out of the total number of patients who were surveyed, okay? N is the total patients sampled. Let's come here, okay? So technically speaking, this X stands for the number of successes. In this case, the number of successes would be the number of patients with that high deducible plan in that showed the sample percent to be 80%. Okay, so this is to do with the sample. So focus on the bottom part, sample. So the sample proportion is given to us, meaning sample proportion is 80%. 80% of those 90 patients had this overdue bill. Okay, so I'll come here. P hat was 80%. So this is 80% of 90 patients, right? This is 80% of 90 patients. So we're going to use this information to find X. Now, this is a relation between P hat, X, and N. P hat is X over N. Now, they didn't give us the X explicitly, but they did give us P hat. So you know that if you did mathematical rearrangement of these terms, your X can be solved so that you have X equals N times P hat, isn't it? Because you can find X as the number of patients with the overdue bill. So N would be 90 in this case. P hat is given to be 80%, so 0.8. So go ahead and multiply those two, and that will give you 0.8 times, 0.8 times 90 is 72, right? 9 times 8, 72. And that is what you bring back here and write X as 72. Now go to your calculator and punch all these numbers here, 0.65, 72 for X, because you can't just enter the 80% anywhere directly in this setup. So it's it's 72 for X, 90 for N, and then choose the greater than and then hit calculate. And this is what you get. Your results would be, upon doing the calculate, the results would be, it shows like this: prop greater than 0.65. Z is 2.983470949. If you recall, that was your answer from part B, right? We did that manually, but see, that's the same answer the calculator gives you. Then this P is 0.0014250645. P hat is given to be 0.8. That is really important because if you entered your X correctly, then the P hat that it calculates from your X also shows correctly. So you know that you did the right job if you see all these values showing up nicely. Now, out of all these, you would have used this information. Let me just circle that. You would have used this information that as your test statistic. And this information is actually your p-value that they're asking in this part, p-value. So this part C says find the p-value. Let me take you back there just to refresh what the question was. Find the p-value is part C. So we found the p-value to be you can always round it to 4 places if you want, because you will need at most 4 places if you were using the table. So P is 0.0014. Okay. Now we did all this using the calculator where we didn't really think about, is it left-sided, left-tailed, right-tailed, or two-tailed. We didn't do all that. We just did it by the p-value method using the calculator. So there are many details that we don't see explicitly. It's all done in the background. Okay. But let's hold on to this, and I will say, oops, I meant to say calculator. So we have that. And I'd like to show this also using the table method. So the p-value with the table method, okay, would require for us to first determine if it is one left or right-tailed or two-tailed. So for that, I look at H1, right? That's my step or part A. The H1, it has a greater than symbol, right? H1 is P greater than 0.65. Let me come down here. H1 is P greater than 0.65. Because of the greater than symbol, it means it's right-tailed. So all of it lies on the right tail, right? So it's all on the right tail. When I say all of it, I mean your alpha lies on the right tail. So you have now, forgot what alpha was. Was 0.1. So all of 0.1 lies on the right tail. So that means 10% is on the right tail. The rest on the left would be the 90%. Okay. Now you need to take your test statistic. Statistic was, let me just pull it right from here. Z equals 2.98. Let's just round it to 2 places because I'm using the table. I need only up to 2 places for the Z value. So then I go to the Z table and then I locate 2.98. And where does it meet? That's where it meets, right? 2.9 here and 0.08 meets at 0.9986. Come back here. Now this 0.9986, I apologize, not Z, 0.9986. This information is actually for the area to the left, right? Because that's what the table tells us. But we are interested in area to the right. This is what we're interested in, right? This is what we want. Therefore, you'll have to take your table value. Table value is 0.9986 for right-tailed test. It implies your p-value must be obtained by doing 1 minus this 0.9986. And if you did the calculator, use the calculator for 1 minus 0.9986, you get 0.0014. That's what we got here is as the p-value from the calculator. The calculator gave you more places, decimal places. We rounded it to 4 decimal places. So this is how you differentiate between the calculate and the table method. And so in your assignments or homework assignments, if it asks you for a left tail, right tail, two-tailed, it's just checking if you still understand the manual method of getting this using the table method. Even though we encourage you to use the calculator, we want you to know what happens in the background, right? So we got that. The p-value, we were able to establish both the table method and the and the calculator method. This is just the p-value method. There is another way to calculate this, which is the critical value region, and we're just going to focus on the p-value here. Then the last one says the D, part D says, determine the conclusion and interpretation for this test. Okay, so to D. Okay, so for this, again, let's go to the steps. So we just did step 6, right? Step 6. Now we have step 7 to do, and then we would be able to make our conclusion. Step 7 related to p-value method says, reject H naught if p-value is less than or equal to alpha. Fail to reject H naught if p-value is greater than alpha. So even though we're asked to answer step 8, we need to do step 7. Let me go over there and do step 7. So step 7 says, reject H naught if p-value is less than or equal to alpha. Okay. So, and then fail to reject. It's all about H naught, remember that? So if p-value is greater than alpha. So I'm going to mark my p-value and my alpha. So p-value is 0.0014 and alpha was 0.10, right? So I need to mark or put the right inequality symbol in between to explain this relation. So if you look at this, p-value is definitely less than the 0.10. So because it's less than, this is the decision we make. We make the decision to reject H naught. Okay. So then I come down here. And so that's your step 7. Step 8 would be using this table here, conclusion table, right? So if we reject H naught, then I have this and this, one of these two, the first or the third to conclude from. So for that, I need to go to H1 to see where my claim sits. If my claim is in H1, I will use the first row. If my claim is in H naught, then I'll use the third row. So let's come over here and check where our claim sits. So we go, our claim, you see here, we said claim sits in H1, not H naught. So claim is in H1. So that helps us to decide that if claim is in H1 and we reject H naught, we have to use the first row for conclusion. There is sufficient evidence to support the claim that. So I'm going to come here and put all these things together and say claim is in H1. And we just decided the decision was to reject H naught. This implies, then I will say, this is the interpretation. There is enough evidence about the sentence of it. There is sufficient evidence to support the claim that, just say sufficient, to support the claim that the proportion of patients, then use the claim, okay? From the problem, pull that sentence, that the proportion of patients with high deducible health plans who have overdue medical bills is greater than, so we are rejecting H0, which means we're saying, well, there's sufficient evidence to see that this is greater than 65%. So there is sufficient evidence to support the claim that the proportion of patients with high deducible health plans who have overdue medical bills is greater than 65%. Yeah. So that is your problem here, where we conducted the hypothesis testing, and we went, even though there were only 4 parts to the question, we technically did all the 8 steps to arrive at the answer. So we cannot really skip steps and move on. Well, you could have done all these things on the calculator, but then you must understand that to make the conclusion and interpret and all that, you should be able to, at least be able to see those 8 steps clearly. So we got that, so that's good. And we also got to use the calculator, even better. So here's the next problem. A nurse would like to test the claim that the percent of male adults visiting the doctor's office who have a 23.1 BMI is less than 42%. The nurse samples 60 male adults and determines the sample percent to be 40%. At the alpha equals 0.10 significance level, test the claim. Again, we read the problem until you understand this. A nurse would like to test the claim that the percent of male adults visiting the doctor's office who have a 23.1 BMI is less than 42%. So you know there are male adults who are visiting the doctor's office. Among them, those with 23.1 BM is those who have that BMI value is less than 42%. That's what she wants to test. And for that, she samples 60 male adults, okay? And among them, she finds the sample percentage to be 40%. So among the 60 adults, right, 40% of them have a 23.1 BMI. That's what it means. And at the alpha equals 0.10 significance level, test the claim. So let's go back and again look for clues. We look for the keywords. A percentage, percent or proportion indicate the same. So remove all the clutter and you see the percent is less than 42. Okay. The percentage of male adults, of course, this percentage is too less to understand. The percentage of male adults, okay, with the 23.1 BMI is less than 42%. And then the sample is 60 male adults, and the sample percent corresponding to that is 40%. Alpha is 0.1. All right, here again, they didn't say use the P method or P value method or the critical value method. But if you go down to A, B, C, D, A is null and alternative hypothesis, B is calculate the test statistic, C says find the critical value or values. They didn't explicitly say find the P values. That means they do want us to find the critical value method here. So we're going to adjust our step 6 in the in conducting our hypothesis test to critical value method. And D is to conclude and interpret the test. Okay. Let's go to part A. So in order to do this, we have to start with step 1. Step 1 is to identify the claim. We identify the claim as the percentage of male adults with 23.1 BMI to be less than 42%. Okay. Of male adults with 23.1 BMI is less than 42%. Okay, so go for the clue. Percentage here indicates the proportion. And remember, your claim is always about the population, so population proportion. With BMI, okay, all that is less than, use the less than symbol. And 42%, we write it as a decimal, 0.42. All right, we got step 1, rather step 2, sorry. Went a little ahead then. That is step 2. And step 3 is where you're actually answering the question. So H0 always carries the equal, so P equals 0.42. H1 in this case, would be your plane. And please write that because we will need it for the plane. Then B is to find or calculate the test statistic. So here too, we can look at step 4, which is alpha, and we are given alpha to be 0.1. And step 5, you could use the calculator to get your test statistic. You could use a calculator to get both test statistic and p-value, but we can use it for the test statistic here because p-value is not asked. Before that, though, you have to do the check. Okay. NP must be greater than or equal to 5, and NQ must be greater than or equal to 5. So go ahead and identify your N and your P and your Q. So I want to see what N is. N is the number of samples. So samples, the nurse samples 60 male adults. So, you know, your N is 60. P is, out of that, the sample percent is, oh, I'm so sorry. P here is just your population proportion. So you just have that here. You don't go to the sample. You just go to 0.42. Q is 1 minus P. And so use your calculator again. And 1 minus 0.42 comes out as 0.58. And multiply your N, 60 times 0.42. And here's 60 times 0.88. Okay. That comes out to be 25.2. That is good. It's greater than 5, right? And then you have this. That is 34.8. Both are greater than or equal to 5, so we're good. So go to your calculator. Okay. SAT tests 1 prop Z test. Okay. Again, I insist that you look at the 1 prop Z test, not the interval on that. That's a step or a couple of steps down, further down. Okay, so for P naught, X, and prop equals, not equals, sorry, P naught, because equals is always here. H naught less than P naught or greater than T naught, and calculate. So I got all of these. And I need to quickly get my X over N. So I have P hat given to be P hat is your sample percent. It's given to be 40%. So come down here and you have 0.4, 40%. X is found by doing N times P hat, right? Where do you write that? X over N is your P hat, which implies X is N times P hat. So N is, forgetting that, N is 60. P hat is 0.4. So multiply that to get 24. Come back here. The P naught is 0.42. Remember, this is your population proportion from plane. Because you have the P hat and the P naught. P naught is a notation that the calculator uses. We would just use P, lowercase p, but here they use P naught, so please be clear on that. X is 24, N is 60. And because you go back to your plane and see what symbol we used, your symbol was less than, right? So, again, look at the plane, right? And then hit calculate. Once you hit calculate, you get, again, a list of values. Out of those values, this is of interest, that your Z is negative 0.31388241103. Okay, you have the p-value. Look at the p hat. P-value, let's ignore that for the moment. P hat is 0.4, which is matching with the 40%. So we did find the X value correctly. and n is 60. So check all the others. And this is our test statistic. So let's come back and answer the question. Right. So to answer the question, we say test statistic is z equals negative 0.31388244103. But you can kind of round it to, because it's a z value, you know, we want 3, maybe 3 places. That's good enough. 2 should do, but 3 is fine. We got that. B, then go to C, find the critical values. Critical values. So let's quickly take a look at our critical value information here. It says find the value of the test statistic and the critical values. To do that, draw a graph showing the test statistic, critical values, in the critical region. Okay. So let's go back here. And again, go back to your H1. H1 has P less than 0.42. The less than indicates that you're going to use a left-tailed test. Okay. So draw your graph. And this time you're going to mark the left tail. Your alpha, which is given to be, alpha is 0.1, right? Alpha is given to be 0.1, and that is taking up your entire left tail. Okay? Alpha is 0.1 on the left tail. So now we come back and use that area. That's your area. You want to find Z, okay? Z for this 0.10, Z value for this alpha. Now this is already the area from the left. Therefore, you know that you could use the table value directly. So you need to go to the Z table and locate 0.1. Okay. You're not going to find an exact value for 0.1 in using the table method, but try to get something that's as close to it as possible. Okay. So I'm scanning through this and I find that 0.1, this seems to be the closest, right? 0.1. So look at its corresponding z-score, down, left, and up. So that comes out to be negative 1.28. So for 0.1, the closest we can find is 0.1003. And of course, that is the area. This is the area, right? What's in the body of the table is the area. And you're trying to find the z value because that is what we're going to use to determine the critical region. So you go to the z value. Z value is negative 1.28. That's the value that separates this critical region, this green shaded region, from the non-critical region. So z score comes out to be, this value is negative 1.28. That makes sense because it's on the left. The left end of the left tail end should be a negative z. That's a z negative 1.28. Now we go to our test statistic. That is the z from the test statistic, which came out to be negative 0.313. Right? So we got negative 0.313, and we need to see where this value lies. Now, this value, again, for perspective, you know that this is your z equals 0, right? This is a z scale, so z is 0. So the negative, the value that we have, the z test statistic, is going to be somewhere there, right? Negative 0.313. Okay. Maybe negative 1 is somewhere here, negative 1. So negative 0.313 is over there, which is outside the green shaded region. Okay. So then I'll come back and say, since z test statistic lies outside the critical region, That's the shaded region, right? So that's the green shaded region. Because it's not in the rejection region, we will not reject it, right? It implies we fail to reject H0. How do I know this? Well, we recall that this was in our step, right? In the decision, step 7, it says, reject H0 if the test statistic is in the critical region. Fail to reject H0 if the test statistic is not in the critical region. And we found that it was not in the critical region. Negative 0.313 lies outside the critical regions. Therefore, we fail to reject H0. Now, to answer part D, which is to interpret this decision, we have to again go back to the table for decision making, the conclusion. So we have failed to reject H0. So we are in this, we will either use the second row or we will use the fourth row where we have failed to reject H0 conditions. However, it depends on where the claim sits. So go back to our claim. Claim sits in the alternative hypothesis. So claim is in H1. So I'll come back here. Claim is in H1 and we fail to reject H0. So we use the second condition. There is not sufficient evidence to support the claim. Come over here and we'll put them all together. So to answer part D, I say claim is in H1 and we fail to reject H0. These two conditions together tell us that there is not enough evidence or sufficient evidence come back here to support the claim, because for the other one it would have said to warrant rejection, right? Here you have to say to support the claim. That, and then pull the question statement that the percent of male adults visiting the doctor's office who have a 23.1 BMI is less than 42%. So we do not have enough evidence to support this claim that the adult male with BMI 23.1 is less than 42%, right? So we fail to reject H0. Therefore, we have not enough evidence to support the claim. All right, so I hope the conducting testing hypothesis and the steps involved in it is made clear here. So we're done with chapter 9, and I will see you in the next chapter in the next video. Here.